Okay, shall we start now? Okay, now listen to me. Before writing the heading, let me ask you a few things. Let us try to understand this topic in a different way. Okay, now tell me, do you remember this equation? F is equals to G m1 m2 upon r square. What is this equation? Gravitational force. Now, so this one is from gravitational force. Similarly, I think you guys are also familiar with F is equals to K Q1 Q2 upon R square. What kind of force is this? Electrostatic force. I think you guys have studied the introduction about the gravitational force and the electrostatic force in your school level. Yes or no? So, gravitational force is applicable. This formula is applicable for, can I say, two masses? Can I? So, let us try to understand this. Let's say this one is your M1 and one more body is being over here. This is your M2. How many bodies are there? Two bodies. Okay. Let's say the distance between them is R. Okay. Now, how many bodies? Two bodies. Gravitational force is always attractive force. We all know this. Yes or no? That means, can I say that M try to attract M2 in this direction? Yes. And similarly, M2 also tries to attract what? M1 in this direction. Yes or no? So, M1 is trying to apply force in this direction and M2 is trying to apply the force in the opposite direction. Can I also say that we already know that from that equation, how much force they are applying? Equal amount of force. But in what direction? Opposite direction. That means, can I say that force, this is the direction of what? Force on 1 because of 2. Yes. This body is trying to attract this mass now, M1. Similarly, who is applying this force? That means force on 2 due to 1. Yes? Okay. So, how many bodies are there? Two bodies. Two bodies, two different forces. Two bodies, two different forces acting in what? Opposite direction and equal in what? Magnitude. Yes? Similarly, let also say that here is your charge. Let's say this one is plus Q and let's say this one is your minus Q. Okay. Or the other is also positive. Either you will be having what? Two positive charges, one is negative or the other is negative or the both negative charges, whatever it may be. Okay. Let's say this one is your 1, this one is your 2. Okay. Now tell me, there will be a force of attraction or repulsion? Repulsion, obviously, like charges repels each other. That means, can I say that over here, this is the direction of what? Whose force? Q2's force on what? Q1. That means, can I say that this is what? Force on 1 due to 2. Similarly, Q1 is also negative, tries to repel this one. In which direction? In this direction. That means force on 2 due to what? 1. Yes or no? Either they attract each other, either they repel each other. That means over here, positive try to attract this one in which direction? In this direction. That means over here and negative tries to attract in this direction. Again, how many forces? Two different forces on two different bodies. Yes or no? From here, we can also say that, one more example, let us try to understand. Consider two bodies are being placed here. Like this, let's say this one is your body number 1 and this is your body number 2. Two bodies. Okay. Now tell me, if there is acceleration or there is no acceleration, whatever it may be, can I say that N1 over here and N2 over here, two bodies? Okay. Where do N1 tries to act? It tries to push this object in this direction. Nah? Yes or no? That means, can I say that this is the direction of normal which is exerted by N1 on whom? N2. Similarly, N2, that means body 2 try to repel this body in this direction. Yes or no? With what? Equal amount of force. So, N1 is also equal to over here N2. Yes or no? Similarly, over here, I can also say that force on 1 due to 2 is equal to 2 on 1. Over here also I can say that. But all are in opposite directions. Yes or no? So, can I say that minimum we are having two forces on how many bodies? Two different bodies. They are equal in magnitude. They are equal in what? Magnitude, and they are opposite in what? Directions. Yes or no? So, from here only, the topic that is what? Newton's third law begins. According to the Newton's third law, what do it states? For every action, there is equal and opposite reaction. Okay, the statement is very simple, but there are some hidden conditions to satisfy Newton's third law. Okay, so better write on now the heading, that is what Newton's third law. Okay, shall I everyone written the heading now? Okay, now let us try to understand what is the statement. For every action there is equal and opposite reaction. That means, can I say that action should be equal to what? Reaction. Action is equal to how much? Reaction. How many forces are there? One should be acting as what? Action. Let's say F1. F1 is acting as what? Action. Let's say F2 is acting as your reaction. That means, can I say action and reaction must and should be equal. If we are considering how many forces? Two forces. These two forces can also be called as what? Action-reaction pair. They are called as what? Action-reaction pair. But they are called as what? Action-reaction pair. But if they satisfy the condition of Newton's third law, if they satisfy the condition of what? Whose? Newton's third law conditions, then and then only we can say it is two forces are called as what? Action-reaction pair. Okay, let us try to understand the conditions. Okay, condition number 1, it says that those two forces, that means action and reaction, must and should be acting on two different bodies. Two different bodies. Just now we have understood two masses. There is a gravitational force, force of attraction. How many bodies are there? Two bodies are there. Are yes or no? Similarly, between two charges, are there two bodies? Two normals are there. Are yes or no? So, how many bodies we require? We require two different bodies. One on one body, one should be action. On the other body, there should be a reaction. Are you got my point? Okay. Similarly, there is one more condition. Two bodies may or may not be in contact. These two bodies can be in contact. They cannot be in contact. Let us try to understand. For example, there is a bar magnet like this. Over here is your north, here is your south. One more over here is your north, over here is your south. If I keep in a range, can I say these two get attracted to each other? Are yes or no? It will become like this. Are yes or no? They are in contact. Even though before getting contact, there is no contact between them. Still there is what? Force of attraction. Yes or no? Okay. So the second condition, it may or may not be in contact. Okay. Two bodies, there should be minimum two bodies. Two forces acting on two different bodies. This condition number 2, they can be in contact or they are not in contact. Okay. Condition number 3 is what? Forces must be equal and opposite in direction. So that means, can I say that magnitude should be equal? Magnitude of those two forces what? Equal, and they should be opposite in direction. Okay. This is the third condition. Let us try to understand the fourth and the final condition, and this condition is very, very important. Again, they should be of same nature. Now let us try to understand the meaning of what? Same nature. Two masses we have taken. Let's say this one is your M1, let's say this one is your M2. Two masses. Force of attraction is there. Are yes or no? Gravitational force, obviously. Can I say that body 2 will try to attract M1 in this direction, body 1 try to attract in this direction? Yes or no? What kind of force is this? Gravitational force. What kind of force is this? Gravitational force. These two bodies are having equal amount of force, opposite in direction. Both forces are what? Same nature. That is what? Gravitational force. I got my point. Similarly, in the charges we discussed that. Let's say this one is your P minus Q, and over here is what? Plus Q. Plus Q and minus Q. Okay. They are separated by whatever the distance is. This one is being attracted by minus Q. Yes. And this one is attracted by what? Positive Q. Still, forces are opposite in direction, equal in magnitude. Okay. They are not in contact. They are not in contact. Two bodies again. But what kind of force are there? Both are electrostatic force. I got my point. Similarly, in one more example, we discussed what? Two normals now. Okay. Let's say this one is your body 1, this one is your body 2, N1 and N2 both are acting in the opposite direction. Both are normals we have considered. Yes or no? That means the same nature means both two forces should be originated from what? Same source. I got my point. If there is a gravitational force, the other should be gravitational. If one is electrostatic, the other should be electrostatic. If one is what mg, the other should be mg. If one is normal, other should be normal. I got my point. So what are the basic conditions? There should be what? Two forces. Two forces must and should be acting on two different bodies. They may be in contact or they are not in contact. Both should be of same nature. Both forces should be equal in magnitude. Both forces should be opposite in direction. If these are the conditions which are being satisfied by any two forces, okay, any two forces, then those two forces are being called as what? Action reaction pair. And we can say only two forces are called as action reaction pair if they follow the conditions of what? Newton's third law. I got my point. Then after writing the heading, just write what? For every action there is equal and opposite reaction statement. Then explain these conditions. I got my point. Okay, right on. Okay, shall I? So your doubt is normal and mg are action reaction pair or not. Let us try to understand this. Okay, normal and mg are not action reaction pair. It look like they are. For example, a body is there on surface, one body is being kept, let's say m mass. Okay, mg is acting in the downward direction and normal is acting in the upward direction. Normal is yes equal to mg. Normal is equal to what? Mg. That is true. But these two forces are not coming under the action reaction pair. They are not action reaction pair. Let us try to understand that. Okay. When do we find normal? When they are in contact. Yes or no? Let us try to understand this. Consider this is your earth surface. Okay, this is your earth surface and let's say here is one body. Okay, and this one is having mass m1. Let's say this one is having mass m2. Okay, where do mg acts? In what direction? Can I say that this is the direction? So this is your body 1, this is your body 2. Now tell me, there will be a gravitational force or not? Yes. Where do this m1 try to attract m2? In the downward direction. So this is the direction of what? Which force? Force on 2 due to 1. Na? Yes or no? Similarly, can I also say that the second mass also try to attract m1? Yes. In which direction? In the upward direction. So can I say this is force on 1, on due to 2. Force on 1 due to 2 is in the upward direction. Force on 2 due to 1 in the downward direction. Who is trying to attract this? Earth. Let's say this is your earth. Okay. Earth is trying to attract this mass in the downward direction. Similarly, this mass or the block is trying to attract the earth in the upward direction. Okay. Let us move. Now, consider this is your earth surface. Okay. And let's say the body reached here. They are in contact with each other. Yes or no? Okay. Now, can I say that earth try to repel or the push in the upward direction? That is nothing but your normal. So, who is applying the force in the upward direction? Earth is trying to apply the force in the upward direction. That is your normal exerted by, let me write like this, normal exerted by earth. This is the direction. Yes or no? Similarly, can I also say that this block will try to press the earth in the downward direction? Whose direction is this? Normal exerted by block on earth, on block. Can I say that? Yes or no? Check the directions. This is the direction of what? Force of attraction on what? Block due to earth. This is the direction of what? Force on what? Block or earth? Earth by the block. Similarly, whose direction is this? Earth direction. Earth is applying normal in the upward direction. Block is applying the what? In the downward direction. Yes or no? Generally, we write like this. This is your surface and this is your block. Over here is N. over here is mg. Are yes or no? Who is applying this mg? Who? Earth is applying the mg, na? Who is applying this normal? Again, Earth is applying. So this is nothing but, can I say that, force due to 2 on 1? Are yes or no? And again, this is what? Normal exerted by what? Earth. In which direction? In upward direction or on block. Are yes or no? So these two forces are being applied by whom? Earth itself. Are yes or no? So we can say that this is the direction of mg and this is the direction of what? M2g. Both are in opposite direction. That is the reason mg and mg are action reaction pair. mg and mg are what? Action reaction pair. Normal and normal are action reaction pair. But never say that normal and mg are action reaction pair. Why? This is the direction of normal which is exerted by whom? Earth. This is the direction of what? mg, which is again applied by whom? Earth. I got my point. On whom? On block. And what are the condition? Basic condition. Two forces must and should be acting on two different bodies. Both should be equal in opposite direction. Yes or no? Who is applying this force? Who is applying this normal? Earth. Who is applying this mg? Earth. Are yes or no? These two forces are on single body. These two forces are not by two different bodies. Are yes or no? Aaya samajh mein? So always remember that mg and mg are action reaction pair. Normal and normal are action reaction pair. I got my point? Never say that normal and what? mg are in action reaction. I got my point? Likh lo isko bhi. Now write down one small topic, that is what? Breaking strength of string. Breaking strength of string. Okay. We will discuss the same topic again in circular motion. Okay. Now let us try to understand. In our previous classes, what kind of string we are using? Non-breakable string. Are yes or no? Unstretchable and unbreakable. But now, every material on this planet or anywhere will be having certain limits now. Are yes or no? Similarly, again, now what we are considering, there is a string. Consider here is a string. Okay. And this one string is being tied over there. Okay. Now, this string, I said that this string can hold the maximum tension. What word I am using? Maximum tension. Okay. Maximum tension, let's say, of 1000 Newton. How much Newton? 1000 Newton. If I apply one block over here, if I apply a block or connected a block over there and whose mass is what? Let's say 50 kg. Mass is what? 50 kg. What will be the force because of the mg? Can I say 500 Newton? Will this string get broken out? No. Why? Because it can hold a maximum tension up to how much? 1000 Newton. Are yes or no? So the breaking strength is nothing but maximum tension which can be bared by a string. Okay. Over here, breaking strength is nothing but what? Maximum tension a string can bear. Okay. Maximum tension a string can bear. That is nothing but your breaking strength. Now let us try to understand. Come over here. So how much I applied the mass? 50 kg. Because of that 50 kg, how much Newton we got in the because of mg? That is what? 500 Newton. If I increase the mass till let's say 1000 Newton, sorry 100 kg, I will be getting mg, that is nothing but 1000 Newton. Will the string get broken out? No. Still, how much force we are having? Tension and what? mg, both are equal. If I increase a bit mass, let's say 100.1, then I will be getting what? 1001 Newton. Are yes or no? 1001 Newton means the maximum tension this string can bear is what? 1000 Newton. Then this string gets broken down. Are yes or no? That means, can I say that T will be the given tension? Let's say T will be the given tension on the string. And T naught is the maximum tension. T naught is what? Maximum tension that string can bear. T naught is what? Maximum tension that string can bear. And T is what? Given tension. by any mean, given tension by any mean, either the mass or whatever it may be, given tension. If T is equal to T naught, will the string get breaks? No. So no breaking. If, can I say, T is smaller than T naught, can I say still unbreakable? No breaking again. Okay, so let's say this over here is 500 Newton, breaking strength is given 1000 Newton, it won't break. If, can I say that T is greater than T naught, obviously it will breaks. So what is the breaking strength? Breaking strength of a string is nothing but what? Maximum tension a string can bear. Maximum tension a string can bear, that is what? Nothing but breaking strength of a string. I got my point. Write down this. Okay, shall I return now? Now listen to me. Consider here is one string. Okay, and consider there is a man who is holding this one. Okay, there is a man who is holding, just holding. So velocity of this man is 0 and the mass of this man, let's say 100 kg. That means, can I say that 1000 Newton is acting in the downward direction because of what? mg. And can I also say that T naught is given, T naught, that is what? Maximum strength of a string is given 1000 Newton. Okay, will the string get broken down? No, first thing. Now let us try to understand. This man is trying to go in the upward direction, first option. Either he is going in the downward direction, okay, but he is keeping the velocity constant. Keeping the velocity what? Constant. Then can I say that if either going in the upward direction or either going in the downward direction, velocity is what? Constant. If velocity is constant, what is the acceleration? Obviously 0. So acceleration is what? 0. Then can I say that the equation for over here can be written as T naught is nothing but mg. T naught is nothing but what? mg. So maximum tension and maximum weight of that person is what? 1000 Newton. Are yes or no? Okay. Now let us try to understand this. The man is trying to move in the upward or downward direction with some acceleration. Okay. Consider the same man over here, and this man this time is going in the upward direction with some acceleration. Okay. Let's say braking strength is again given, T naught is equals to what? 1000 Newton. Okay, and the mass of this man is given 50 kg. What is the mass of this man? 50 kg. And give and ask that find the acceleration in this question. Find the acceleration of man so that string do not breaks. String do not break. Let us try to understand this one. Okay. अबे क्या लिखते रहते रहे? सुनो पहले. Okay. What is the mass of this man? 50 kg. Yes or no? Maximum tension that of a string is what? Breaking strength? 1000 Newton. First tell me, A is moving in the upward direction. He is moving in what? Upward direction. That means, if I want to write the equation for this, then can I be writing that T naught is the maximum tension. T naught is the maximum tension, so we are calculating for the maximum tension itself. Okay. So T will be greater or mg will be greater. Who is greater over here? That is what? How much? Mass 500 Newton. Acceleration is in the upward direction. Obviously, bigger force minus a smaller force. Why? Because tension will be acting in the upward direction. And what tension we are considering? Maximum tension. Okay. So T naught minus of mg, which is equals to what? Ma. Can I write like this? Okay. What is the maximum tension? 1000 Newtons. Okay. And mg is what? 500 Newton. And mass of this man is 50 into acceleration. That means 500 upon 10. So acceleration can be written as 10 meter per square second. Okay. If the man is moving with an acceleration that is what 10 meter per square second in the upward direction, till then string won't break. Smaller than this acceleration, never breaks. Greater than this acceleration, definitely the string will get breaks down. अरे समझ में आया रे. So how we are calculating acceleration? By using what? Maximum tension. That is what? Braking strength. Now stop doing and tell me the answer for this. Again, T naught is given 1000 Newton. सोच के बोलो आंसर. Okay, T naught is what? 1000 Newton. Okay, and again there is a man. There is a man who is holding this string, and this time the mass of this man, let's say 200 kg. Mass of the man is what? 200 kg, and this time he is accelerating in the downward direction. Before telling me the answer, just tell me the answer. If the man is at rest or in motion, either in upward direction or in downward direction, 3 questions I will ask you. If the person is at rest, question number 1 on this one, what will be the mg? 2000 Newton. Braking strength is how much? 1000 Newton. Are yes or no? Will the string get breaks? First thing, yes. If he is at rest or moving with a constant velocity, definitely there is no option other than braking. Definitely the string breaks down. Yes or no? Okay. Question number 2. If he is going in the upward direction, tension compared to that increases or decreases? Question number 2. Will it break or not? Definitely it will break down. Why? Whenever it is going in the upward direction, either देखो equation देखो, check this equation. This is the equation when we written for the upward direction. That means, can I say that T is nothing but ma plus of mg. Ma plus of mg. At rest, what we are having? T naught is nothing but mg. Who is greater? If a person of 100 kg, having and the braking strength of string is what? 1000 Newton. What I am saying is, braking strength of this string T naught is 1000 Newton, and one person is over here and whose mass is what? 100 kg. Because of this 100 kg, what is the mg? 1000 Newton. If this man is moving in the upward direction or he is at rest, that means V is 0 or V is constant, string never breaks. Why? Because T naught is over here is equals to what? mg. It never breaks. But the same person of same mass, if he is accelerating, if he is what? Accelerating, same mass, same person, like this. Again, T naught is what? 1000 Newton. And this person, same person, 100 kg. Because of 100 kg, downward direction, 1000 Newton. Are yes or no? Tension is what? 1000 Newton. If he starts to accelerate, accelerate in the upward direction, then can I say tension will be increased? Whose tension? T is greater over here than T naught in this equation. Can I say that? But when the same person of 1000 what mass? 100 kg mass is moving with constant velocity or he is at rest, string never breaks. Okay, why? Because acceleration over here, acceleration is what? 0. Same person on the same string, if he is accelerating in the upward direction, definitely I will be having tension greater to the braking strength. Greater than what? Braking strength. Obviously it will break. Why it breaks? Because our equation says that T over here becomes greater than what? Ma plus of mg. Tension is increased by ma. Are yes or no? Definitely this time the string breaks down. But now the question is, what if 200 kg person is moving in the downward direction, accelerating in the downward direction, okay, but the braking strength is 1000, will it break or not? सोच के देखो. Why? Yes, very good. This time the equation becomes over here is nothing but T minus of mg or mg minus of T? Yes, mg minus of T, which is equals to ma, that is T naught. Okay, then if I want to write the equation, then I will be writing mg minus of ma is nothing but T naught. Tension increased or decreased? Decreased. I got my point. Same person can be accelerating in the downward direction on this string, then tension decreases. Arey aaya kya? Then can we calculate the acceleration over here? Yes. What to calculate then? Chalo yahi kar denge. Calculate and tell me the acceleration for this one. Okay, let me check your answers. Then over here I will be writing mg minus of T naught is equals to ma, and mg is how much? 2000 Newton. Minus of how much tension, that is what? 1000 divided by mass is what? 200. That is nothing but your acceleration. 1000 divided by 200, that means acceleration is 5 meter per square second. Yes. So when a person is how much mass? 200 kg mass. Even that braking strength is what? 1000 Newton. He can accelerate in the downward direction by what? Positive acceleration. That means in the downward direction, even though string never breaks. I got my point. So write down one point. Completed now, everyone. Okay, write down one point. Whenever the acceleration is in the upward direction, like this, then tension increases. And whenever the person is going in the downward direction, tension decreases. अच्छे से याद रख लो ये points. Okay? Right on.